All right, moving on to example number 2 of tangent line finding using implicit differentiation. So here, what we are given is the equation x squared plus y squared is equal to 1. You might recognize this from algebra as being the equation for the unit circle centered at the origin, i.e. the graph that you see in black at the right here. And the goal is to find the tangent line to the curve at the point root 2 over 2, root 2 over 2, i.e. the blue point that's drawn on the unit circle. And we want to find the equation of that red line passing through that point that touches at exactly the blue point. All right? Turns out we don't necessarily need to solve for y to do this. Implicit differentiation gives us all the tools that we need, provided that we are given an x and a y value on the graph. All right? So how do we do this? Just like we did in the last example. So step 1 is find dy dx, which is going to be the slope of our tangent line. To do that, we need to implicitly derive this equation. So derive the first term. This gives you 2x. Then you add on the derivative of the second term. So put some parentheses around this y to remind you to use the chain rule. So you bring down the 2, subtract 1, and then multiply by the derivative of the inside. So you have 2 parentheses y to the first times the derivative of the inside, which is going to be y prime. Okay, so that takes care of that. We do not need this 1 here because anything to the first power is just that thing, and these parentheses don't need to be here either. It was just a helpful tool to remind us to use the chain rule. Then on the right-hand side, the derivative of 1 is just 0. So there we go. So now our task is really easy when it comes to just trying to find y prime. So what we're going to do is subtract this 2x from both sides in order to get the y prime stuff on the left-hand side. So we have minus 2x from both sides. And then rewriting this gives us 2y, y prime is equal to minus 2x. Okay, final step is divide both sides by this 2y in front of the y prime because we're trying to get y prime by itself. So we divide both sides by this and then rewrite because it's the right thing to do. Makes mathematicians happy when they're grading your stuff. And then you can cancel out your 2's, leaving you with minus x over y. That's cool. All right, so that gives us our y prime. Or if you like, our dy dx. Same thing. Okay, so we also have a point. So we have the equation necessary for finding the slope at a given point. As long as we have an x value and a y value given to us, we can always find the slope, simply by plugging in points into the x and the y. Our goal is to find the slope at this point, this root 2 over 2, root 2 over 2. So every place you see an x, you're going to replace it with the root 2 over 2. Every place you see a y, you're going to do the exact same thing. Replace it with the root 2 over 2. So I like to be wordy in how I do this. So I say at square root of 2 over 2, square root of 2 over 2, y prime is equal to minus root 2 over 2, because that's what the x value is. And then we have in the denominator root 2 over 2 again. So simplifying this, hey look, I have the same thing in the numerator and the denominator. Yes, you could use fraction rules, but it's more or less the same thing as if you just notice we have a parentheses on the top that is equal to the parentheses on the bottom, so these things kill each other, giving you exactly minus 1. Okay, same thing on top, same thing on bottom, they kill each other. All right. So our slope at the point root 2 over 2, root 2 over 2, is minus 1. This is the m that we need for the slope of our tangent line here. All right. So now we need to find the equation of the tangent line. Find equation of tangent line. So this is what we did above. We found the slope. Now we need to use point slope form, which says y minus y0, where y0 is the y value of a point on your line, is equal to m, which is your slope of that line, times x minus x0. And now we can substitute in appropriate information. Our y0 and our x0 are going to come from this and this, respectively. So you replace your points, your x0 and your y0 with those things. Similarly, your m is equal to minus 1 by what we found above. So, continuing on, we plug in what we have. We have square root of 2 over 2, y minus square root of 2 over 2, and then we have minus 1 times x minus square root of 2 over 2. Okay, a little distribution never hurt anyone. Maybe it did. Maybe it resulted in the death of someone somewhere, but don't like to think about those things. Math is usually harmless. You have minus x plus square root of 2 over 2. Okay, so all I did was distribute this thing, this minus 1. So it changed the signs. All right, so what does that imply? My goal is to get a y is equal to mx plus b formula, so we have y is equal to, okay, so I'm going to add this root 2 over 2 to both sides to cancel it off. So I have minus x plus root 2 over 2 plus root 2 over 2. But what does that equal to? I have 2 root 2 over 2's. So I have x minus x plus 2 root 2 over 2. The 2's kill each other, leaving you with minus x plus square root of 2. So there you go. There you have it. That is the final answer. That is the equation of your tangent line at this point. Hopefully that makes sense. That's the equation of this red line, and that was example number 2. Give example number 3 a shot. It's a little bit more complicated because it involves some trig, but I think you can handle it. So, see you in the next one.